Okay. So hello to everyone who's watching on YouTube. Since no one has joined the session yet, I'll be starting in about 5-10 minutes so that a few people can join the session. So if no one else joins in 5 to 10 minutes, then I'll just start without anyone. But yeah, let's wait for like 5-10 minutes before starting. Okay, so I guess since no one has joined the session yet, I guess we'll start without anyone. So just to reintroduce myself to the YouTube audience, whoever's watching on YouTube. So hello everyone, I'm Lakshya Saggi, the discrete maths problem solving TA for these Monday 6 to 8 p.m. NPTEL sessions. Uh, I could not hold the session this Monday because of power cut, so we are holding the session this time on Tuesday, 6 to 8 p.m. But from next time onwards, the session will only be from Monday, 6 to 8 p.m. again. So yeah. So this will be, I believe, our fourth session, and in this session, I'll be discussing about about problems related to relations. So basically, reflexive relations, transitive relations, symmetric relations, and equivalence relations. And I'll be assuming that you guys, while solving the problems, I'll be assuming that you guys have gone through the lecture videos first. And yeah, so we'll focus more on problem solving. But yeah, if some need arises, then I'll discuss some of the definitions also. So yeah, I guess in that case, we can get started now. So I'll just share my screen and yeah, I'll just share my screen and we'll start solving the problems. Okay. So we have the first question. So first question says that which of the following matrices represents a reflexive relation? And it's a multiple options correct question. So what is a reflexive relation first of all? So okay. So maybe first of all, let's just go through the question. So we are given four matrices for relations, and now we have to find out which of the following matrices represent a reflexive relation. So first of all, let's just revise what does this matrix representation of a relation actually mean. So what does this actually mean? Like, what's the relation in this matrix? Like relations are what we have heard, like a subsets of sets of the form A cross B. But here we are just given matrices. So as discussed in the lectures also, I'll just revise those definitions again. So what is a matrix representation? Uh, okay, so someone has joined the meeting. Okay, so hi Abhishek. We have just started discussing the problems. I've just started discussing the problems. So I'm at the first question only. So yeah. So the first problem asks which of the following matrices represents a reflexive relation? And it's a multiple select question. So multiple options can be correct. And these are matrices given to us, and we have to find out which of the following represent a reflexive relation. So first, I'll just be discussing, like this has been discussed in the lectures also, but still, uh, what does the matrix representation actually mean? So matrix representation of a relation over a set S. So uh, in the matrix representation of a relation over a set S, what we mean is that the I comma jth entry of the matrix is one if and only if ith comma jth element are related to each other. Ith comma jth elements of S belong to the relation R. So suppose we are given the relation R and yeah, yeah. So we have a relation R and we want to find out its matrix representation and the relation R is over a set S. Then we say that the matrix I comma jth entry is one if and only if ith comma jth element of S belong to the relation R. Okay, so then what we can say here is okay. One second, guys. Okay, hi. Sorry for the issue, guys. So there was some issue with the Wi-Fi, so I have changed the Wi-Fi now. So yeah, so what I was discussing was ith comma j, I comma jth entry of the matrix is one if and only if ith comma jth elements of S belong to the relation R, and this is how we define the matrix entry. So what? So for example, consider the matrix A. Then we see that the second row's first column has value 1. So what this means is that suppose the set S has three elements A1, A2, A3, then A2 comma A1 is part of the relation R. If this entry is 1, then A2 comma A1 is part of the relation R. Similarly, if this entry is 1, this is first row and third column. So A1 comma A3 is part of the relation R. And all the zeros are not part of the relation. Similarly, A3 comma A3 is part of the relation R. So these are different relations over different sets, and we can actually write out these relations also. Okay. So now let's also revise maybe like so we want to find out which are the following represent a reflexive relation. So what's a reflexive relation? So reflexive relation says that A comma A belongs to R. So for all A in S. So I hope everyone understands like what reflexive relations are. So they just say that for every element A of the set S, the uh, the tuple A comma A should be part of the relation R. So what this actually means is in terms of these matrices, what this means is that AI comma AI. So I'll just write, so what I'm assuming is I'll just list out all the elements of the set S by A1, A2, A3, and so on. So A subscript I denotes the ith element of the set S. So so this statement, uh, like if S is if the relation R is a reflexive relation, this just means that A, let's just say all the elements are denoted by AIs, then AI comma AI should belong to the relation R for all AI in S. So I have just written this in this form, like both of these statements are equivalent, but just written this down in this form. And this is because this just denotes that ith comma ith entry should belong to R for all AI in S, right? So this just means, so when we come, so if this is true that AI comma AI should belong to R for all I in S, then what does this mean in the form of matrix representation? Like if I comma jth element of S belong to the relation R, here both i's are equal. So this is I comma I. Then effectively I comma ith entry of the matrix should be 1. Right? So basically entry at ith row, comma ith column is equals to 1. So to identify, and what does this mean? Like for all I, and this is true for all I. So in a matrix, if for all ith row comma ith columns entry is 1, this means that like this denotes all the diagonal entries of the matrix. And so effectively a matrix, the matrix representation represents a reflexive relation if and only if all the diagonal entries of the matrix are 1. So all diagonal entries are equal to 1. So this is how we represent reflexive. So for a matrix representation to denote a reflexive relation, all diagonal entries should be equal to 1. And in which, and we have to identify in which of these matrices we actually have diagonal entries equal to 1. So the option A, we can see that uh, the second zero, there's in this diagonal entries, the second element, the 2 comma 2th element is 0. So all diagonal entries are not 1 in option A. So option A does not represent a reflexive relation. In option B, we can see that all the diagonal entries like, are 1 except this last one. The fifth comma fifth entry is 0. So this is also uh, not a reflexive relation because this entry is 0. Okay, maybe I should just write down option by option. So let's just see option A. So option A does not denote a reflexive relation. Not a reflexive relation. Not reflexive as 2 comma 2 with entry. 2 comma 2 entry is 0. Similarly for option B, we have that in this option, this is not this is also not reflexive because fifth comma fifth entries not reflexive. And 5 comma 5 entry is 0. Now we see option C. In option C, we can see that all diagonal entries are 1. So option C is actually reflexive. Similarly, option D. In option D, we see that again all diagonal entries are 1. We only have to see the diagonal entries. Other entries do not matter to us in case of reflexive relations. So option D is also reflexive. And similarly, option E is also reflexive. So I hope this makes sense. So I see that Akansha has joined us. So hello, Kansha. So if there are any uh, doubts in what I'm explaining, or if there are any like if there are any technical issues with my voice, or if my screen is not visible, then you can just inform me via chat, and I'll try to rectify those issues. And also, like if there are any doubts, you can also ask in chat. I'll try to answer them to the best of my capabilities. So yeah, there's that. Okay. So this is how, so in this question, the correct answer is effectively options C, D, and E. So which are the following matrices represent a reflexive relation? So answer is C, D. Hence, options C, D, E are correct. Okay. Okay. So suppose the question was a bit different. Like here, the question is asking which of the following matrices represent a uh, reflexive relation. But instead, what if the question asked instead about a symmetric relation? Like if the which of the following matrices represents a symmetric relation? In that case, what can we do? Uh, so just a food for thought for you guys. So if question asks instead for symmetric relation, then what can we do? So again, just going back to the basic definitions, we'll be able to see how can we obtain the matrices. So what's the symmetric relation? So symmetric relation means that if A comma B, if a tuple A comma B is in the relation R, then the tuple B comma A should also be in R. Right? This is what a symmetric relation is. So what this effectively means in terms of the matrix entries is that if So what this means is that suppose I denote all elements by the indices A1, A2, A3 till AN, if there are n elements in the set S over which this relation is built. Then what we effectively have is that if any pair of elements AI, AJ is in the relation R, then the element AJ, AI is also in R. This is how we'll define symmetric relations, right? This is how uh, we'll say that this is a symmetric relation. And what does this mean in terms of matrix entries? So in terms of matrix entries, this means that if AI, AJ is in R, then AI, AJ and then I, jth entry of the matrix should be 1, right? So this means that if I, jth entry is 1, then this should also happen. And what does this mean? This just means that j, ith entry should be 1. Then j, ith entry is 1. So if I, j is 1, then j, I is 1. And these kinds of matrices have a special name. And this is like these kinds of matrices are called symmetric matrices. Like we have studied these in high school also, I believe. So this implies that matrix should be a symmetric matrix. And what's a symmetric matrix? Like what symmetric matrix? Like this, that I, j entry is what, like the matrix is actually symmetric along the diagonal, or what we call as the matrix M is actually, so that is the matrix M is equal to M prime, where M prime is the transpose. Or maybe I can just write transpose. This is the symbol for transpose. So if the matrix M is equal to its transpose, then it's a symmetric matrix, and a symmetric matrix represents a symmetric relation. We have just shown this. So which of these options would then be symmetric? Akansha, would you like to answer this? Uh, which of the following matrices will represent a symmetric relation? Akansha is typing something in the chat. Okay, so Akansha says options A and E. Okay, so Akansha says option A is symmetric and E is symmetric. So Akansha, in option A, I think A is not symmetric because you can see this. So along the diagonal, the matrix is generally symmetric, right? So if you can see this entry, this is 0. This entry lies at the first row and second column. So this is 0, but the entry at second row and first column is 1. But in symmetric matrices, I, jth entry and j, ith entry are equal, right? So if these two entries should have been actually equal for it to be a symmetric matrix. But I see that one entry is 0, one entry is 1. 1, 2 entry is 0 and 2, 1th entry is 1. So this is not a symmetric matrix. So option A is not a symmetric matrix. Similarly, option B is also not symmetric, as we can see that this one lies at the third row and fifth column. So 3, 5th entry is 1, but 5, 3th entry, the entry at fifth row and third column is 0. So these two entries are not equal. And so this matrix is also not symmetric. Similarly, in option C, again, this entry, first row, second column, and second row, first column, these two entries differ. So it's also not symmetric. And in option D, again, okay, so in option D, again, it is not symmetric because we see that this entry, second row, fourth column, and the entry, fourth row, second column. Okay, second row, fifth column, and fifth row, second column. These two entries are differing. Like this is 0 and this is 1. So that's why this is also not a symmetric matrix, because for all ij, this is not true that I comma jth entry is not equal to j comma ith entry. But note that in option E, uh, like entry 2 comma 1 is actually equal to entry 1 comma 2. So all entries, so this is actually a symmetric matrix. Like for all ij, I comma jth entry is equal to j comma ith entry. So only option E is symmetric. Option A is not symmetric. Does this make sense, Avansha? So only option E is symmetric. Okay, nice. It makes sense. That's good. So now we come to the second question then. So these are just very basic questions to get you guys started to just revise the definitions for you guys. So yeah. So second question says that suppose the set A consists of Srijit, Akash, and Rupesh, and set B consists of Shraddha and Sanchita. And now the question asks which of the following subsets belong to A cross B. So what we have is we have given two sets, and now we want to find out which of the following options are actually subsets of the set A cross B. So to answer this, we'll just first find out what is A cross B. So A cross B just means, like, this must, you guys must have seen the lectures, but I'll just revising. So this means Cartesian. This represents the Cartesian product of sets. And like, how do we define this? So for every element in the set A, we'll take a tuple of it with every element of the set B. So what I mean is, so this is also a set. The set A cross B is also a set, and its entries will be all possible pairs from A and B. So suppose we take Srijit. So entries of this set will be Srijit, comma Shraddha, and the second entry will be something like, okay, I should copy probably this. The second entry will be, so Srijit, comma Shraddha is covered, then Srijit can also be paired with Sanchita. So this will be then Sanchita. Then the third entry will be, so Akash can be paired up with Shraddha and Sanchita. So we'll replace here Akash. So Akash can be paired up with Sanchita and Shraddha. So this is also possible. And then other other pairings are Rupesh can also be paired up with Shraddha and Sanchita. So this will be okay. I think I somewhat made a mistake here. So here it is Srijit, and now what we want is Srijit from Sanchita and replace it by Akash. So first we see Srijit, Shraddha, Srijit, Sanchita, then Akash, Shraddha, then Akash, Sanchita, and then we'll have something like, I'm just copying here. And then we'll pair up the Shraddha and Sanchita with Rupesh. So Rupesh, Shraddha, Rupesh, Sanchita. So this will be Rupesh. Rupesh. So this will be the set A cross B. So the elements of the set A cross B are these 6 elements. This is the first element, this is the second element, this is the third, this is fourth, this is fifth, and this is sixth element. And now we have to find out which of the following options belong to A cross B. So this is again, we'll check it option by option. So let's see option A. So is so for this set to be a subset, all of these elements should belong to all of the elements of this set should belong to the set A cross B, right? So we check element by element whether all of these elements belong to the set A cross B. So does Srijit, Shraddha belong to A cross B? We see that Srijit, Shraddha is present here also. So this belongs. Rupesh, Shraddha is also present. So this is also in a set A cross B. Similarly, Akash, Sanchita is also present. And Srijit, Shraddha is also present. So option A is a subset of A cross B. Then we come to option B. Option B says Rupesh, Shraddha. So Rupesh, Shraddha is present actually. So this element is present. Akash, Shraddha is also present in A cross B, this entry. And Sanchita, Srijit. So note that these so the set A cross B. So Sanchita, so we see that Sanchita, Srijit is not present in the set A cross B, but in set Srijit, Sanchita is present. So this is a very important distinction, guys. I want you guys to keep this in mind that these two pairings are actually different. So Sanchita, Srijit and Srijit, Sanchita are different entries because we have defined the set as A cross B. So first element should belong to the set A and second element should belong to the set B. Here what is happening is Sanchita, Srijit actually belongs to the set B cross A because the element of set B comes first and then element of A comes. But this is not we want. What we want is the first element should be from set A and the second element should be from set B. So this element actually Sanchita, Srijit does not belong to the set A cross B. Even though one might think, oh, Sanchita and Srijit both are present here also. So why does their ordering matter? But it matters. This is because this is how Cartesian product of sets is defined, that the ordering is also important. So Sanchita, Srijit does not belong to the set A cross B. So not a subset. So not a subset as Sanchita, Srijit does not belong to A cross B. I hope this makes sense. Then we come to option C. In option C, what we have is Akash, Akash. So this can easily be seen that Akash, Akash is not present here. The second elements are only Shraddha and Sanchita in the set A cross B. Akash is not present in set B. So yeah. So it is also not a subset. And why is it not a subset? So I can just put it as Akash, Akash does not belong. Then we come to option D. So option D says Srijit, Shraddha. So Srijit, Shraddha is present. Shraddha, Shraddha is not present. Right? So again, option D is not a subset also. So note that all entries should have been a part of A cross B. If we encounter even one entry which is not part of A cross B, then it is not a subset. I hope this is clear to everyone. So in this question, we see that only option A is the set A is only the subset of A cross B. So only option A is correct. Hence, option A is correct. So I hope this makes sense to everyone. If it does not, you can ask me via chat. Okay. Then we come to the next question. And this is a bit of an interesting question. So the question asks, what is the total number of reflexive relations of the set 5, 7, 13, and 15? So for this, we'll need to go back to the definitions of relations, like what actually is a relation. So would I, first of all, would anyone like to answer this in chat before I start discussing this? So any of like Ojas or Akansha, you guys like to answer? Okay, so Ojas and Akansha are saying that the answer should be 2 to the power 12. Okay, so nice guys, actually you are correct. So yeah, the answer for this actually it would be 2 to the power 12. So I'll just discuss this anyways for the YouTube audience also. So where will watch on YouTube. But yeah, good job, guys. Your answer is actually correct. So we know that the size of the set S, the S which is given to us, the size of the set S is actually 4. Like there are 4 elements in there are actually 4 elements here. So, and how do we define a relation? A relation is defined as any subset of a relation over a set S is defined as any subset of S cross S. So any subset of S cross S will be a relation. This is how we define a relation over a set S. So note that since size of set S is 4, the size of set S cross S will actually be 4 times 4, which will be 4 times 4, which is 16. So number of possible relations. So another question here. So total number of possible relations is equals to number of possible subsets of S cross S. So what will be the total number of, like, let's just not talk about reflexive relations, but guys, what will be the total number of possible relations? We know that a relation is a subset of the set S cross S. So total number of relations will be just the number of possible subsets of S cross S. So how many possible subsets? Okay, so Akansha has written just directly the formula for the number of reflexive relations over the set, but we'll just go through the theory also. How do we arrive at this formula? Okay, so Ojas has written that the number of possible subsets will be 2 to the 16. So good job, Ojas. This is actually correct. So number of possible subsets of S cross S will be, uh, so there are 16 elements in S cross S. And this we have covered earlier also when we were discussing power sets and stuff, that number of possible subsets of a set X is just 2 to the cardinality of X. And here the set X is just S cross S. So cardinality of S cross S is 16. So this is the number of possible subsets. And now what we want is a reflexive relation, right? We want the number of reflexive relations. So we know that total number of possible relations are the 16, but note that not all of these relations will be reflexive. Some can be reflexive, some might not be reflexive. So, but for a relation to be reflexive, so the element A comma A should be in R for all A in S. Like this definition we have already covered. So all elements of the form A comma A should be present in the relation R. Only then will the relation be reflexive. And other possible tuples can be present or they might not be present. We don't care. But all the tuples of this form should be present. So what does this mean? That the relation R must contain So what elements must be contained in the relation R? So the set S contains 4 elements, 5, 7, 13, 15. So for all of these sorts of elements should be present. So 5, comma 5, 7, comma 7, 5, 5, comma 5, then 7, comma 7, then 13, comma 13, and then 15, comma 15. So these 4 elements must be present in the relation R, right? So actually, initially, how did we arrive at this formula for total number of possible subsets of S cross S? We said that there are total 16 elements in S cross S, and we have choice over all of these 16 elements, whether to include these elements or not include these elements. But note that now we have fixed that like these 4 are also part of these 16 elements, right? We have fixed that these 4 elements must be a part. And for others, we have a choice, but these 4 must be a part of the relation R. So what this means is that these four uh, these 4 choices have actually been fixed, and we don't have a choice for these 4 choices. So now we don't have a choice for all these 16 elements of S cross S. We only have a choice for the remaining 12 choices. Like out of these 16, 4 have been fixed. So only the remaining 12 elements have a choice whether to be included or not. So what this means is that we only have a choice to include or exclude the remaining 12 elements. And what does this mean? This implies that total number of reflexive relations will be equal to 2 to the power 12. And this will be the answer. So I'll just hold it, or maybe I'll just calculate its value. 2 to the power 12 is a small number. It will be something like 1024, 20484096. So yeah, this will be the answer. I'll just write it like this. So I hope this is clear to everyone. So yeah. Now suppose again, I'll just like to twist the question a little bit. Instead of the total number of reflexive relations over the set, what if we were asked the total number of, let's say, symmetric relations? So, any guesses? Instead of, if we were asked instead of total number of reflexive relations, we had to find total number of symmetric relations. Okay, so Ojas has written 2 to the power 10. So actually correct, Ojas. So yeah, correct that the answer will be 2 to the power 10. But I'll leave this as exercise for you guys. Like, how does this come out to be? To the power 10. Answer is 10. Yeah. So the high level idea for determining this 2 to the power 10 is again same as here. So like here what I said was that we have initially we arrived at total possible subsets as 2 to the 16 because we had 2 choices for each of the 16 elements. But now 4 of those were fixed. And because of this, we only had 12 remaining elements on whom we had a choice to include or exclude. Here, what will happen in symmetric relations is that if you fix the I comma jth entry, if you choose I comma jth entry as something, then j comma ith entry will also be fixed. So if you choose one entry, then second entry will also be fixed. This will only be true for non-diagonal entries because for diagonal entries, we don't have exactly a mirror image possible. So when you do the calculations, the high level idea is what I have just described. It will come out to be 2 to the power 10. So I hope this is clear. Another question can be just I'm just thinking about this right now. I don't not think about it earlier, but what if we were asked about total number of equivalence relations? Okay, let's leave it like let's not discuss a lot of stuff on the fly. But yeah. Okay, so Ojas is typing something in the chat. So Ojas, do you have a doubt? Okay, okay, sure. So now maybe we can go on to the fourth question then. So fourth question just says that given us, so again, it's a very straightforward question. Given the set S equals 1, 2, 3, 4, 5, a relation R on the set S is defined as R equals to B comma A such that B minus A is greater than equal to 0 and less than equal to 3. And now what is the cardinality of the set R? Okay. So maybe I'll just move this question to the next page. So yeah. Okay, so the question says that we are given the set 1, 2, 3, 4, 5. A relation R is defined as the pairs from this set such that their difference is bounded from 0 to 3. So now we want to find out how many such numbers are possible. So what is one brute force manner to solve this? So brute force approach, a straightforward approach would be uh, so find for all elements of S cross S. So what do? We just for all elements of the set S cross S, uh, just check if the condition B minus A less than E. So if this condition holds true. So just check for so S has a cardinality of 5. So S cross S will have a cardinality of 25. 5 into 5, which is 25. So for all these 25 elements, just check if the condition holds true. And the number of elements for which this condition holds true will just be the cardinality of the set R. Number of elements for which this holds true will be the cardinality of R. So this is a brute force approach. Here we'll need to check like something like 25 elements, right? For all elements, we'll need to do something like this, do this checking. So like you can do this, but this will be a bit time consuming. So what we can do instead, we can employ a smarter approach. And what will be a smarter approach here? Just take different cases of A. Take different cases of A. So what I mean is that we know that so value of A would be a better term. So we know that A can only take the values from 1, 2, 3, 4, 5, right? So just let's just make all of those cases. So maybe I should just, yeah. So the first case would be when A is equal to 1. A can only take the values 1, 2, 3, 4, 5. So if A is equal to 1, then what we have is that B minus 1 should be less than equal to 3 and should be greater than equal to 0. So I'll just put it here. So if A is 1, then we have that B minus 1 is less than equal to 3, less than equal to 0. And this implies that B should be between 1 and 4, right? Just taking 1 to the both sides. So between 1 and 4, we can take all these 4 values. So this implies that there are 4 possible values of B here. So you need not check for all possible values of B like putting B as 1, 2, 3, 4, 5, you just straightforwardly have that B is between 1 and 4. And so there are only four possible values of B, 1, 2, 3, 4. Similarly, the second case will be A equals 2. When A is equals to 2, then B minus 2 will be greater than 0 and less than 3. And this will then become from B will be from 2 to 5. Again, we have B's value as 2, 3, 4, and 5. So again, we will have four possible values. The third case will be, so A can take all of these values, right? 1, 2, 3, 4, 5. Third case will be when A takes the value 3. And when A takes the value 3, we'll have B minus 3 will be less than equal to 3 and greater than equal to 0, from which we'll get the bound on B as something like 3 to 6. So note that B has a value from 3 to 6. But 6 is not present in the set S. So B cannot take the value 6. The only values B can take is 3, 4, and 5 here. So we only have three possible values of B here. Because between 3 to 6, only three elements of the set have this value. Similarly, if we had A as 4, then we'll have B minus 4. Here we'll have something like a 4 and something like a 7 here. And now again, only 4 and 5 are the possible values of B. And similarly, when A equals 5, we'll have B minus 5. And so this will be a 5 and an 8. And so there will just be, so B is between 5 and 8. So only possible value of B is 5 from the set S. One possible value of B. So total possible values for B comma A would be just summation of all of these cases, right? All of these cases are disjoint. A is 1, 2, 3, 4, 5. All of these cases are disjoint. So this means that for finding out the final answer, we just need to sum up these cases. So it will be 4 plus 4, 8 plus 3, 11, 11 plus 2, 13, 13 plus 1, 14. So it will be something like 4 plus 3 plus 2 plus 1. And this will come out to be 14. And so this is the final answer. So yeah. And you can easily list out those values also for which this holds true. So when A was 1, the values of four possible values of B were like 1, 2, 3, 4, right? So 1, comma 1, 2, comma 1, 3, comma 1, and 4, comma 1. Similarly, when A was 2, we had again four possible values from 2 to 5. So the four possible values here are 2, comma 2, 3, comma 2, 4, comma 2, and 5, comma 2, and so on. So you can list out those 14 cases also. But here, like 14 is the correct answer for the cardinality of set R. I see that Ojas has also answered in chat the answer 14. So good job, Ojas. The answer is correct. Yeah. So here we only needed to check these 5 cases, right? We did not have to make of all the elements in S cross S and check if this condition holds true. We just took these 5 cases and we were able to answer much faster. So yeah, sometimes like there are smarter approaches and brute force approaches. Okay, so now let us define. So let's come to the fifth question then. Fifth question says that let R be a relation on a collection of sets defined as follows. So we have a collection of sets and R is a relation over these collections. So R is a relation where a tuple of sets, so A and B both are sets, and they are related to each other if and only if A is a subset of B. So we are given a lot of sets, and two sets A and B are related to each other if and only if A is a subset of B. And now, so this, I hope everyone knows that's the symbol for subset. So now we want to answer which of the following statements are correct. So let's come to this option by option. So option A says that R is reflexive and transitive. Okay, so let's come to transitivity later. So first let's see reflexive. So is this relation R reflexive? So would anyone like to? Okay, so Ojas has already answered the question that A comma C. Okay, guys, let's come to this as option by option. Like, let's not straightforwardly come to the answer. Maybe I could discuss it myself. So option A says that R is reflexive and transitive. First check for, let's just first see if it is reflexive. So if for a relation R to be reflexive, what we need is that A comma all elements of the form A comma A should be in R for all A. And how will, and for this to happen, so we know that an element is a subset of itself, right? So since A is a subset of A for all A, like A is always a subset of A, right? Hence the R is reflexive. So we know that for R to be reflexive, A comma A should be in R. And what does this mean? This means that A should be a subset of A, which is actually true. And hence R is reflexive. And now for R, okay, and now for R to be transitive, what we want is, I hope everyone knows what transitivity means, that if A comma B is in R and B comma C is in R, then A comma B should also be in R. This is what we call transitivity. And for testing the transitivity, we know that like for if A comma B is in R, this implies that A is a subset of B, right? So now suppose A comma B is in R and B comma C is in R. So we know that A is a subset of B and B is a subset of C because A comma B is in R and B comma C is in R. And now is it true that A comma C will also be in R? Like we can just see that A is a subset of B and B is a subset of C. So all elements of A are contained in B and all elements of B are contained in C. So this easily implies that A is also a subset of C, which means that A comma C is in R. So the relation is transitive. So option A will hold true. Now we come to option B. Option B says that R is symmetric. And what does symmetric mean? Symmetric means that if A comma B is an element of, if A comma B belongs to R, then B comma A also belongs to R. But note that like if A is a sub, if A is a proper subset, let's say there are two sets. So what I mean is, so first of all, this is not symmetric. Like I'll just answer this straight away. That not true. And why is this? So consider A equals 2. A is the set 2 and B is the set 2 comma 5. Right? Then A comma B is in R because A is a subset of B. But B comma A is not in R because 2 comma 5 is not a subset of 2, right? So B comma is not in R. A comma B was in R, but B comma A was not in R. And this means that R is not symmetric, right? For R to be symmetric, A comma B is in R, then B comma A should also be in R. So R is not symmetric. Then comes option C. Option C asks us about antisymmetry. So I hope everyone knows what antisymmetric means. So antisymmetric means that for R to be antisymmetric, what we have is for all B not equal to A. So this symbol, by this symbol, I mean not equals. Like this exclamation equals to, I denote it as not equals. For all B not equal to A, what we want is if A comma B in R, then B comma A not in R. So for all elements, for all sets B not equal to A, if this condition holds true, that if A comma B is in R, then B comma A is not in R. If this whole condition holds true, then R is said to be antisymmetric. And here we see that here we'll see that it actually will turn out to be antisymmetric. And why is this the case? So consider A comma B such that B is not equal to A and A comma B is in R, right? So what does this imply? This implies that since A comma B is in R, this implies that A is a subset of B, right? And also that B is not equal to A. So note that if A is a subset of B and B is not equal to A, then it can only be a proper subset. So this means that A is a proper subset of B. This means that there exists an element in B which it does not lie in it. There exists an element of B which is not a part of A. And okay, something like that. And what does this imply? If there is an element of B which is not a part of A, this means that A can't be so B can't be a subset of A, right? So because there exists an element of B which is not of A. So A cannot be a subset. So A is not a subset of B. And what does this mean? Okay, sorry, B is not a subset of A. And what does this mean? This means that B comma A is not in R. And this means that hence R is anti-symmetric. Right. Now let's go to option D. Option D says R is reflexive but not transitive. But here we have already shown that R is in option A and R is reflexive and transitive. So this is incorrect as R is transitive. And we have already shown transitivity in option A. Okay, so we see that only option C said antisymmetric. So option C is correct. Option B is incorrect. Option A is correct. So only option A and C are incorrect. Hence, options A, comma C are correct. Right. And I see that Akansha had answered that options A and C. So good job, Akansha. Your solution was correct. Ojas wrote option A, comma B, but so there's I think option B is not correct. Instead, option C is correct. So I hope it's clear to everyone. Now we can uh, move on to the sixth question then. So sixth is again a simple question. So sixth question says that uh, let a relation R be defined as R is A comma B, where uh, A and B both live in the same city. And then we need to find out the correct statements. So what we have is if A comma B are related if and only if they live in the same city. So option A says that R is antisymmetric. So maybe we'll come. Okay, so maybe we can start with antisymmetric only. So for antisymmetricity, what we want is for all B not equals to A. Maybe we can start with first of all reflexivity. Like reflexivity is the first property. Let's first take reflexivity. Reflexivity. So is this relation are reflexive? So like for the reflexivity, all elements of the form A comma A should be part of the relation R. So this means that A and A should live in the same city. And this is trivially true, right? Like a person and that person itself live in the same city. So reflexive as A and A live in the same city, right? Then we have transitivity. Let's just go to transitivity then. So A and B, suppose A and B live in the same city. If A comma B live in the same city and B comma C live in the same city, then we can say that like if A and B live in the same city, let's say the city was let's say Delhi, and B and C also live in the same city. So we know that A and B both live in Delhi, and we know that B and C live in the same city. We know that B lives in Delhi, so C must also live in Delhi. And so A, B, and C, all these three live in Delhi. So A and C also live in the same city and hence are related to each other. So then A comma C will also be in the same city and hence R is transitive. Right. And now let's go to symmetric. So is R symmetric? So Akansha has already done the answer as BCD in the chat. So yes, Akansha, your answer is actually correct. So good job, but I'll just explain this. So R is symmetric also. And why is it the case? R is symmetric because if A and B live in the same city, so if A comma B belongs to R, what is symmetricity? If A comma B belongs to R, then B comma A should also belong to R. And if A comma B belongs to R, then A and B in the live in the same city. Then B and A also live in the same city. And hence, uh, okay, maybe I should take that. So yeah. So R is reflexive, transitive, as well as symmetric. So since it is symmetric, like it won't be antisymmetric. So hence options B, C, D are correct. I'll just mention that antisymmetric. It can be easily seen that R is not antisymmetric. And why is it the case for any two different people like A and B? If A comma B live in the same city, then B comma will also live in the same city. So since it is symmetric, it won't be actually antisymmetric. So only option B, C, D are correct. Okay, then I hope it's clear to everyone. Let's go to seventh question then. So seventh question asks us which of the following is an equivalence relation. Okay, now it's an interesting question. So we are given four options and we have to identify which of the following are equivalence relations, right? So first question says that first one says that R is the elements of the form A comma B, where both A and B are non-zero integers and A by B is not an integer. So uh, Akansha, do you think this option A will be like Akansha or Rashmi? Would any of you like to answer? Let's go option by option. Will this be an equivalence relation or not? The relation R. Note that for a relation to be equivalence relation, it should be symmetric, reflexive, as well as transitive. So do you see if any of those properties, if all of those properties hold true or if any of the properties violated? Yeah, so Kansha is saying that it is not reflexive, so it won't be equivalence relation. So yeah, good job, Kansha. So you're correct. Not reflexive. So not an equivalence relation as it is not reflexive. And why is this the case? Since A divided by A is equals to 1, which is an integer. So for a relation to be reflexive, A comma A should be uh, part of the relation, right? But A, if we have A comma A, then A by A will be equal to 1, which will be an integer. So option A is not an equivalence relation. Now we come to option B. Option B says the elements of the form x comma y, where y plus x is equal to 0. So again, same sort of arguments will apply. This will also not be reflexive because uh, like I'll just see tell you guys. So not an equivalence relation as it is not reflexive. And why is this the case? So uh, this is because consider x equals to some element, let's say 2, right? Then x plus x is equals to 4, which is not equal to 0. So this means that x comma x is not related. And x comma x which is not. So this is why it is, since it is not reflexive, it won't be equivalence. Okay. Then we come to option C. Option C says that okay, maybe it should assumptions of following is not an equivalence relation, just for the sake of it. So option C gives these options. So 1 comma 6, the set, the relation 1 comma 6, 2 comma 4, 3 comma 5, 4 comma 8, and 5 comma 6. Is this relation equivalence relation? Like this can also be easily seen that this will also not be like I have asked the question about equivalence, but all of these relations do not even come out to be reflexive actually. So here also we see that there are elements of the form 1 comma 6, 2 comma 4, 3 comma 5, and this, but there is no element of the form, let's say 1 comma 1, right? For reflexivity, all elements of the form A comma A should be present. But here one with one, no one and no second one is present. So 1 comma 1 is not present. This is not reflexive. 1, comma 1 is not present. Okay. And then we come to option D. Option D says the relation of the form A, comma B, where A is not equals to B. So again, I think this will be easy to answer that. Again, this is also not an equivalence relation as it is not reflexive. Like, again, because for if we replace like A, comma A should be part of the relation R for it to be an equivalence relation. But here we see that A is not equals to A is actually false, right? Because A will be equal to A. So A, comma A is not in R as A equals A. So actually all the four relations are not equivalence relations. So options A, B, C, D, all four are correct. And the question, like I changed the question to which of the following is not an equivalence. So all of these are not. The option A, B, C, D are correct. Okay, I hope this makes sense to everyone. If there are any doubts, you can ask me via chat. Otherwise, I'll just move on to the next question now. Okay, so the eighth question now says that suppose cardinality of a set A is 4 and cardinality of a set B is 3. Then what are the cardinalities of the Cartesian product A cross B and the power set of A cross B? So again, this is a simple question. Would you guys like to answer? We have done this sort of question in one of the previous questions also. So what will be the cardinality of the Cartesian product A cross B and the power set of A cross B? Akansha, Rashmi, would you guys like to answer in chat? Okay, so Akansha has answered that the answer should be 12 to the power 12. So yeah, like it's a simple question. So yeah, this was just for uh, again just for the sake of the basics. So cardinality of A cross B we already know is actually equal to cardinality of A times the cardinality of B, which will be nothing but 4 times 3. Cardinality of A is 4 and cardinality of B is 3, so this will be 4 times 3, which will be nothing but equal to 12. Right? And now we also know that the cardinality of power set of so so the cardinality of power set of A cross B will be nothing but 2 to the power cardinality of A cross B. And this will be equal to 2 to the power 12, which will be equal to 4096. And this will be the correct answer. Right. I hope this makes sense. Like this is not too difficult of a question. But yeah, but it still tests the basics of do you guys remember power sets and stuff. So okay. So eighth question is done. Then we can come to the ninth question. So ninth question says that which of the following collection of subsets is a partition of A equals to 1, 2, 3, 4, 5? So the question asks which of the following collection of subsets is a partition of the set A equals to 1, 2, 3, 4, 5. So first of all, I hope everyone, okay, even if everyone does not remember, so I'll just write it down for you guys. So what do we actually mean by partition? So partition of a set S. So what is actually partition of a set S? Partition of a set S is just collection of disjoint. So disjoint is very important word here. Disjoint subsets of S such that the union of these subsets is equal to S. So this is how we define partition of a set. So yeah, you guys may have seen this in the lectures also, but if you have not, then I'll just still revise the definitions for you that partition of a set is just collection of disjoint subsets such that union of these subsets is equal to S. And like so effectively the set S needs to be broken down into different subsets. And what do you mean by disjoint? Disjoint means that the subset should not have any element in common. So two sets are called disjoint, S1, S2, if S1 and S2, if S1 cross S2, if S1 intersection S2 is zero, or the null set. Effectively, what this means is that no two sets have element in common. If no two subsets have any element in common, then they are all disjoint subsets. So what we want is the subset should not have any element in common. Union of the subsets should be equal to S. So in option, let's go option by option. So options A says that 1, 2, 3. Okay, so Akansha has already answered in the chat option D, but let's just see if this is correct or incorrect. So option A says 1, 2, 3, and 2, 3, 4, 5. These are the two subsets. So do these form a partition or not? So as we can see here that what we want is the subset should be disjoint. But here you can see that 3 occurs twice. Like 3 occurs in this subset and as well as in this subset. So this is not disjoint. Option A is this is not a partition as subsets are not disjoint. B is a common element, right? Similarly, let's come to option B. Option B says 4, 2, 3, 1, 5, and 2, 3. So again, we see that first condition that these are again not disjoint because 3 is again a common element in two of these subsets. Note that for all pairs of subsets, there should be disjoint. Like all pairs should be disjoint. So even if we find any two subsets which have a common element, then we'll say that it is not a partition. So since 2, 3 and 3 have a common element 3, then this will not be partition. Not a partition as the subsets 3 and 2, 3 have 3 as a common element. Right. Or maybe just write on that, not disjoint. Yeah. Similarly, we go to option C. Again, in option C, we see option one subset is 1, 5, then 2, 3, then 4, 5. So again, it's very easy to see that 5 is a common element between these two. So this is also not a partition. So I'll just write it down. Not a partition as the subsets 1, 5 and 4, 5 are not disjoint. So let's come to option D then. So in option D, the first subset is 1, 2, second is 5, third is 3, 4. So we see that there are no two subsets which have a common element. So these are all disjoint. But disjointness is not, it's not just disjointness what we want. We also want that the union should be equal to S. So if we take union, then the union of these will be equal to 1, 2, 3, 4, 5, which is actually the set A itself, right? So union is actually equal to set A, and they are disjoints. So this will be a valid partition. Okay, I hope this is clear to everyone. So uh, Akansha had written in the chat option D. So good job, Akansha. Your answer was correct. So just one thing, I just like to add a bit more options so that everyone is on the same page about the partition. So do we call this a partition? Like let's say we are just given two subsets, 1, comma 2 and 3. So maybe like it's easy to see because I've just discussed, but I'll just like to mention this that here we know that the sets are disjoint, right? But if we take their unions, these subsets are disjoint. No two, they don't have a common element. But their union is not actually equal to the original set A, right? They only have one. Their union is only 1, 2, and 3, whereas we wanted 1, 2, 3, 4, 5. So option E is not a valid partition, not a partition, as union of the subsets is equal to 1, 2, 3. But A is 1, 2, 3, 4, 5. Okay. So, and another option which I like to give, like another thing which I would like just like you guys to keep in mind is, so suppose 1, 2, 3, and the second is 4, 5, 6. So this kind of, so another doubt which can arise in one's mind is, okay, so these are disjoint and their union also contains all elements of A. So the union of these two subsets will be 1, 2, 3, 4, 5, 6. So will this be a partition or not? So I just like to point out that this will also not be a partition because we need this to be, the union should actually be exactly equal to A. So it's not that a union is a superset of A or anything. It should be exactly equal to A. And that is why this is also not a partition. Not a partition as union of the subsets is 1, 2, 3, 4, 5, 6, but which is not equal to A. Okay, so I hope these kinds of things make sense. I just wanted to point out to everyone like what exactly is a partition. So here we see that only option D is correct. Hence, only option is correct. Right. Okay, so now let's think about a, suppose if we want, so this is a question like, let's just based on the partitioning, let's just form another question. So what if we are asked to find out the total number of possible valid partitions of A. So in how many ways can A be partitioned? Okay, maybe ways in which A can be partitioned. Okay, so we see this set A and we want to find out how many possible partitions of A are possible. So, for example, like this is a valid partition, the option D, 1, 2, 5, and 3, 4. Another possible partition could have been we took all these 1, 2, 5 together and this 3 and 4 separately. So note that one thing that this partition is actually equivalent to. So partition is just a collection of disjoint sets. So the ordering does not matter. So this partition is actually equivalent to saying that the partition is something like this. The ordering of the subsets does not matter in a partition. What matters is just these subsets which we are giving. Okay, so these are not different partitions. These are same partitions. So just keep this in mind that ordering does not matter in partitions. These two are same partitions actually. Generally, this is how we define partitions. And now suppose we are asked to find out the total number of ways in which A can be partitioned. Like, these are not different ways, but same way. But another way to partition A would be to take 1, 2, 3, 4 together and this 5 separately, and so on. So this is an interesting question. Like I would like to ask you guys to think about it for 5 minutes, let's say. If you can think of it, good, but I'll just give you the answer. You can try it yourself also later. So this is more of a question about permutation and combination. And it's quite a cool question. So if we want to find out the total number of ways in which A can be partitioned. So I'll just mute myself for like 5 minutes. You guys can think about it and whatever thought comes to your mind, just type it out in chat. Like the number of ways in which A can be partitioned. So yeah, it's a cool question. I just want to ask you guys. So I'll be muting myself. If anything comes to mind, just type out in chat if any answer comes to mind. So yeah. Okay. So Rashmi has written in chat that there are 32 possible partitions. So I'll have to I guess I'll have to work out the answer myself also because I haven't solved it yet, but just give me 2 minutes, guys. I'll also think about it. Uh, okay, so okay, let's just solve this here only. I myself don't know, Rashmi, if 32 is the correct answer because I just gave this question on the fly. So yeah, so let's just do it case by case. So suppose we want to find out the number of ways in which A can be partitioned, right? So A is this set 1, 2, 3, 4, 5. So we'll have to divide this problem. Let's just for counting this, let's just divide this problem into cases. So let's divide this problem into cases. And what's the cases? So case one will be something like and cases and how are dividing the cases based on the number of subsets. So note that a partition can, so suppose this was a partition, this had three subsets, right? 1, 2, 3, 4, and 5. Similarly, if there was a partition which had only two subsets, it would be something like 1, 2, 3, 4, and 5. Similarly, there can be partitions with three subsets, four subsets, five subsets. So there will be multiple cases. Number of subsets is 1. So there are, as you can see, there are 5 elements in the set A. So there will be the maximum we can have 5 different subsets. The number of subsets can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It can't be more than 5 because we only have at max 5 elements. So we have to count the number of cases in all of these separately. So this case I claim is trivial. Like if number of subsets is only 1, then how many possible partitions can be there? Like if number of subsets is 1, how many possible partitions can we have? Okay, Akansha is saying 1. So good job, Akansha. So the only possible partition can be the original A. Only as A itself is the subset. Similarly, if okay, yeah, sure. Similarly, if number of subsets is 5, then also I claim that the number of partitions can only be 1. And this is because there are 5 elements, so each of the subset will contain, every subset contains exactly 1 element, right? So one subset is 1, second subset is 2, third is 3, third is 4, and so we have that number of subsets is 1 and 5. These two cases are handled. So these are the important cases for us. So suppose number of subsets is 2. So there are, let's say, only 2 possible subsets. In that case, how many partitions, in how many ways can we partition? This is also, I claim this is quite simple. Like if we have to partition a set into 2 subsets, and the set is like this subset, and how many ways can I partition? So I claim that I can partition this in this many ways. So I just want okay. So I think yeah, I may have been mistaken here. Uh, Okay, so if we want the number of subsets as 2, so there can be multiple cases, right? If one is part of the subset as well as number of possible subsets is 2, then here I think we'll have to divide it into further subcases like okay. So number of subsets is 2. So let's say the subsets are S1, S2. Let's say the subsets are S1 and S2. So I'm just doing this on the fly. I don't know if there is a more efficient solution for this, but I think this might be needed. Yeah. So if number of subsets is 2, let's say subsets are S1 and S2. So case 1 will be like S1 has 3 elements. Okay, so case 1 can be S1 has 4 elements, S2 has 1. And case 2 will be like S1 has 3 elements, S2 has 2. So note that since ordering does not matter in a partition, so we don't say that like we don't need those cases where S1 has 2 elements and S2 has 3 elements, because uh, we are assuming like the ordering of the subsets does not matter. So that's why we only need to handle these cases. Like the first subset, let's say, has 4 elements, the second subset has 1. Similarly, first subset has 3 elements and second subset has 2. So let's say we want to find out the number of cases here. So S1 has 4 elements and S2 only has 1 element. In how many ways can this be done? This is these, if we divide into these two cases, then I believe this becomes quite simple. So would any of you like to answer? Rashmi or Akansha? The second set only has 1 element. And note that we did not include the 5-0 case because then the number of subsets are only 1. That S1 has 5 and S2 has 0. In that case, we did not include. We only because like empty subset is of no use to us. Okay, so maybe I should ask. So this can only happen in 5 ways, right? Okay, so maybe I should mention that this is one way, 5 ways. And why is this? Because S2, sorry for that. So S2 has 1 element which has 5 choices, right? So S2 only has 1 element, and that element can be 1, 2, 3, 4, or 5. Whatever S2 is, S1 will just be the complement of that. So if S2 is 5, then S1 will be 1, 2, 3, 4. If S2 is 2, then S1 will be 1, 3, 4, 5, and so on. So as soon as we choose S2, S1 will be fixed for us. So there are 5 ways here when S2 has only 1 element. Similarly, if S2 has 2 elements, then what we need to do is we just need to choose any 2 of these 5 elements. We just need to choose any 2 of these 5 elements, and that will give us S2. And from that, S1 will just be the complement of that S2. So this will be something like a 5C2. 5C2 ways, because 5 choose 2 ways. This is because there are 5 elements and we need 2 for S2. So this will be like 5 choose 2, which will be something like 5 times 5 minus 1 by 2. So it will be 10. I hope this makes sense. Uh, we have to choose 2 out of 5 elements. S2. So something like this will be the case here. So 10 ways. We'll have 10 ways here. So then, so this case is handled, that number of subsets is 2. Now, if we come to this case, that number of subsets is 3. Uh, let's say the subsets are S1, S2, S3, S4. Okay, then I think the question will become quite long. It will become very calculative in the sense that, like for 3, we'll again have to take the cases of S1, S2, S3, and like S1 has 3 elements, S2 has 1, S3 has 1, and something like that. Okay, so yeah, maybe I think we should uh, like I'm just cheating a bit here, but like let's just not find out for the this array A1, this set 1, 2, 3, 4, 5, because you see that there will be a lot more cases here. Because now if number of subsets are 3, then we'll have something like S1 has 3 elements, S2 has 1, S3 has 1, and then we'll have to do a lot more calculations and subset is just use this set, just the set. Okay. Yeah. Or maybe just let's just do it for 1, 2, 3, 4. Then for 1, 2, 3, 4, we know that if S was 1, 2, 3, 4, then if number of subsets is 1, then we know still that like I'm saying that we don't do it for 1, 2, 3, 4, 5 because it will become a bit lengthier, but we just do it for 1, 2, 3, 4. So for 1, 2, 3, 4, we say that if number of subsets was 1, then we only had one way. And if number of subsets was 2, then the two possible ways were, okay, here we'll also have a bit of an issue. Okay, so S1 has so S1 has 3 elements, S2 has 1. So suppose the first, so if the number of subsets was 2 for this subset, S1 will have 3 elements and S2 will have only 1 element. And this will happen in 4 ways because S2 can only choose one of these 4 elements. So this has 4 choices. Similarly, the second case will be S1 has 2 elements and S2 has 2 elements. And in this case, what we need to do is we just need to select 2 elements for S2. So it can be done in 4 use 2 ways. And this will be equal to 6. So I'm very sorry for changing the question, guys, but I think for this question, we'll be able to answer much faster. So we have to choose 2 out of 4 elements for S2. And now suppose we had number of subsets equal to 4. This case is also handled. So the only non-trivial case left for us is number of subsets is 3. So let's say the subsets are S1, S2, and S3. Right. So first case will be, so let's just assume that number of elements in S1 will always be greater than equal to S2, which will be greater than equal to S3. So the first case will be something like S1 has. So if number of subsets is 3 and total elements is 4, then S1 can only have at max 2 elements. Because if S1 has 3, then S2 and S3 also need to have at least one element, right? All of these sets need to have at least one element. So then only S1 can have 2 elements. So what I'm saying is This is the only case possible. Like no other case is possible. This is what I'm claiming. Because if S1, I'm assuming that S1 had the highest number of elements because we can always rearrange their order because ordering does not matter to us. If S1 had highest number of elements and S1 just has two, then S2 will have one and S3 will have one. If S1 had something like three elements, then one of these should be zero. But we can't do this because we need all of these to have at least one element. And S1 cannot have one element because then S2 and S3 also will have maximum of one element and total number of elements will be less than equal to three. Right? So this is what I'm claiming is this is the only case possible. That S1 has two elements, S2 has one, and S3 has one. And so in how many ways can we do this? And note that ordering also does not matter to us. So suppose S2 had an element 2 and S3 had 4. And in second case, S4 had 2, S2 had 2, and S3 had 4. Something like in one case, this had only 2 as the element, this had 4 as the element. And in second case, this had 4 and this had 2. These two cases should be equivalent to us. So we should not take these as distinct cases. And now we need to find out the number of possible ways for this to happen, right? And maybe I'll just, since we are in your time, I'll just remove the 10th question because we don't need it. It was a simple question and it's better to focus on this question only. So in this case, in how many ways can we find these partitions? How many partitions can be possible? So note that S1 has two elements. So these elements can be chosen in 4 choose 2 ways, right? So the two elements of S1 can be chosen in 4C2, which is equal to 6 ways, right? And as soon as we choose the elements of S1, the two elements of S1, what's going to happen is that there are only two elements remaining. And one of those elements will go to S2 and the second element will go to S3. Right? So suppose, and what I'm claiming is there is only one way in which one element goes to S2 and other goes to S3. This is because suppose 1, 2, let's say goes to S1 here and only 3, 4 are remaining. Then it doesn't matter to us whether S2 gets 3 and S3 gets 4, or if S2 gets 4 and S3 gets 3. Because in both the cases, our partition will be like 3 and 4 will become singular partitions, right? Since we are only interested in the collections, we are not interested in the ordering. So the first subset will get as 1, 2 if S1 gets these two elements. And then it is fixed for us that the next two subsets will be 3 and 4. One subset will be just containing the element 3. The second element will just contain the subset 4. Like the second subset will contain just the element 4. The first will contain just 3. So there is only one way for the remaining two elements to be divided into two subsets. I hope what I'm saying makes a bit of sense. So that's why as soon as we fix S1, we don't need to worry about any other thing. So the remaining two elements are divided one each into S2 and S3. Okay, or maybe form subsets of size 1 each. So what I'm saying is just as soon as we choose the two elements of S1, we'll be done here in counting the number of ways in this case. So hence, total number of ways in this case is equals to 6 and nothing else. So here we have 6 ways. Here we had 4 ways. Here we had only 1 way. Here we have 6. And here also we had 1 way. So I hope what I said makes sense to everyone. It was a bit confusing, but if you guys think about it a little more, I hope you'll be able to get it. So here we had 1 way, then we had 4 ways in this case, we had 6 ways in this case. So it's 6 plus 4 plus 1, it's 11. Then we have 11 plus 6, 17, and 17 plus 1, 18. So the total number of ways partitions is equals to 1 plus 4 plus 6 plus another 6 plus 1, which is equals to 17. So this is our final answer for, okay, I think it's not 17, but 6, 12, 16, 18. Yeah. So this will be the final answer for us if for the set 1, 2, 3, finding out the number of partitions for a set of 4 elements. Like I hope it's clear that it need not be just 1, 2, 3, 4, it can be any 4 elements, and the number of partitions will still remain this 18. And one thing to note is that an important thing here to note is this was one way of counting, but this was a bit involved, right? Similarly, if you had 1, 2, 3, 4, 5, it would have been a lot more cases. So once you learn about recursion once you learn about recursion, it will come in upcoming lectures. After that, I believe this same problem can be solved much more efficiently. But I wanted to avoid talking about something which has not been taught in the lectures. So even though this question may seem very tedious, but once you learn about recursion and stuff, then this question you can calculate much faster. Oh yeah, but for now, I believe this is the correct method, and you'll have something like 18 ways here. Okay. So I hope this makes sense to everyone, and yeah, and we are already like over time, so it's 8:05 now. So I guess uh, we can, if there are any doubts, you can ask me. Otherwise, I'll be closing the session, and you can also leave. So okay, so I don't see anyone type. Yeah. So once again, just thanks for joining the session, guys. Hope to see you guys next week also. The timing will be from Monday 6 to 8 p.m. So yeah, hopefully we'll see you guys next week. Thanks for joining, guys, and bye bye. I'll be stopping the recording now.